Hello everyone, my name is Jacek and I am Technical Business Development Manager in ORing. And today I'm going to present you a very short guide and show you how quickly and easily you can connect your end devices on Modbus protocol to our IoT gateway and send the information from this end device to our cloud platform with MQTT protocol. So let's get started. As you can see, our PaaS, so ORing Platform as a Service Cloud main page is open. And first of all, I would like to focus and discuss a little bit about its features and configuration and technical specification. So for this case, we can go to our developer page right on the right. And after opening it, you can see that here the documentation can show you all interesting and important information about the cloud platform itself. Information including RESTful API, OAuth 2.0 interface, API keys, as well as the most important part, which is MQTT connectivity, topic payload definition, and data logger, so how to connect the device and how to store the data inside the cloud platform. For today's purposes of the demo, we will use MQTT connection because this is the main protocol supported by our cloud platform. So let's go to the MQTT part of the configuration. So as I just mentioned, PaaS is using MQTT as the main protocol. And you can see right now in the screen, our MQTT broker address is mqtt.paas.oringnet.cloud. And we use two different ports depending on the connectivity type. So for open unsecured connection, there is port 1883. And for secured connection over SSL or TLS, there is a port 8083. Another thing is Think authentication. So Think is another name of the device which is actually connected to the cloud. So for each thing which exists in the cloud platform, there are some login credentials which are unique for each device. In this case, we have client ID, username, and the password. Another important part to learn today is a topic payload definition. So in this case, all you have to remember that the topic pattern is a $thing/identity/$data/data bucket identity. And all information for the payload are always sent in a JSON format to our cloud platform. However, you don't have to be worried about this because our firmware is doing the coding for you. And the last part is the configuration of the data logger. So data logger is our mechanism which helps to collect the data from connected devices and later use this data for analysis and historian purposes. And all you have to remember is that the data logger is using two separate variables. In this case, we have a data bucket and a data shape. Data bucket is a variable which is used to aggregate the data and later is related to the MQTT data topic. And the data shape exists inside the data bucket and specifies what kind of data and what kind of values will be sent from the end devices to the cloud. And the data shape later is related to the payload definition. Also important thing to remember is that there are different data types in the cloud platform. So in this case, we support string, integer, float, boolean, hex, and coordinates. And it's very important to remember during the configuration that the type must match from both sides, so the device side and the cloud platform side, because if they don't match, the data won't be able to reach the data logger. Okay, so after we have this basic information about the connectivity and how to send the data to the cloud, let's go back to our main page of the PaaS. But before we start, I would like to also tell a few words about our device, which will be used for the demo today. So in this case, it's our IMG-4312D plus D4G gateway. It's our new release product, which support 4G LTE connection as well as Wi-Fi wireless connection. It has two Ethernet ports, one serial ports, one digital input-output. and supports protocol like Modbus TCP RTU for end-device connectivity and cloud protocols like MQTT, including Spark-Plug-B, also CoAP or lightweight machine-to-machine. So basically, it's very flexible, very universal device which covers many different applications. And because it's industrial grade, it's a perfect solution for harsh environment like a factory floor or field sites where wide operating temperature range and solid design is necessary for the implementation. Okay, so this is the device that is going to be used during the demo. So now I will focus on the cloud part first. So after we have all of this information, let's move on to log into our page. And after you put your credentials, which I already done before, that's why I don't need to do it again, you will be logged and see the main dashboard of the console. The main dashboard is showing you generic information from the system, like how many things there are in the system, what's the connection rate, data usage, map location, and so on. But because we are interested in adding and creating new device in the cloud, let's move on to the Think menu on the left, where you can see all listed devices which exist in the cloud, as well as you can use the Create New button on the right to add a new device to the list. So let's do it right now. To create a thing, first of all, we need to start from adding its basic information like device name. I will name it IMG-4312D-Demo. We can specify the full model name if you like, IMG-4312D. And we can add a unique device serial number, which we can read from the label. For demo purposes, I will quickly skip this part and just put some basic random numbers. And you can describe the device for later information. This is our demo device. Sorry. You have some other settings. We can leave them as they are. And now, because during adding the device to the cloud platform, the system provides us possibility to already create the data bucket and data shape. Of course, you can add them later after the device already exists, but as if the system already provides this feature, why not use it? So in this case, I will add a new data bucket. Let's say that today I will simulate temperature value. So my data bucket will have a name of sensors. And inside of the data bucket, I will add just one value, which will be temperature. I will call it temp for identity, but the alias will be temperature. The value type will be integer, and the unit C for Celsius degrees. Okay, so after we added the basic information about the thing and we created the data bucket and data shape, we can simply click Create button to add the device to the list, and the system will create our new thing. Yes, so after the thing is created, you can see that it's already added with its unique identifiers, which is identity, secret, and client ID, as well as there is a topic definition for command, uplink, and data. And the interface provides a very nice tool which helps you to simply copy these values later to the gateway configuration. And here you can also see this information that we already created, so generic info about the device. Okay, so once the device is already added and we know what value we want to send to the cloud, let's move on to our gateway configuration. So the gateway is already connected to my notebook with an Ethernet cable, and I will use Modbus simulator, Modbus tool to simulate some values with Modbus TCP protocol. In this case, to start the configuration is just enough to enter the IP address of the gateway inside our web browser, which will bring us to our login page. In this case, the factory settings are admin and password, admin, I'm sorry. And once we are logged in, we can start from configuring the basic setting and one part to make our device to be connected to the internet and be online. For one connection, you have different types to choose, like dynamic static IP, PPoE, cellular or wireless client. If you will have a SIM card from a service provider, you can go to the cellular type. And usually the configuration for cellular connection is just related with providing correct APN from the service provider. And because our new model IMG-4312D supports dual SIM, you can use two independent service providers for redundant connection, for cellular redundant connection. However, today I don't have any SIM card, so I will simply use a Wi-Fi for one connectivity. In this case, I'm going to wireless client. And to make this configuration, it's just enough to click the site survey button to list all available Wi-Fi networks around. Yes, in this case, my network will be this one in the row 5. Here you can see it's a security type, so basically all the securities are supported. So it's just enough to choose it from the menu, go to the security drop-down menu, choose the type, specify authorization and encryption, and put the key. And once this is done, we can simply click apply button and wait a while until the gateway becomes online. After it will be connected, you will be able to see that the access point is associated, as well as you will be able to see the WAN IP on the top of the interface. Okay, so as you can see, the status is changed to associated, and we got the WAN IP from our access point. So the gateway seems to be online. Also, you can check this information to this in a system status system info menu, and it's also worth checking with system tools and miscellaneous settings and ping tool to ping any other website to check if the gateway can reach it. In this case, I will try to ping google.com. We need to wait a few seconds for the ping test result, and if it's passed, then this is a very good sign because the gateway is online. Okay, after we have the gateway online, it's always a good manner to first of all change the setting for date and time. In this case, my current time zone is GMT +2, so I will apply this setting for the NTP server. So you can see now that system time of the gateway is matching my time zone. And the same, it's always very good to go to the security of the gateway. Login setting and change the password to log into the gateway to make it more secure. I won't change it for now for demo purposes. And another step, it's always good manner to go to the system log and select all options available here and save these options to have them later in case something goes wrong and we want to troubleshoot. So the logs will help you to list all the messages from the system of the gateway and help you to figure out what is not working. Okay, so after these settings are done, we can simply go with our gateway configuration for the cloud platform. This configuration is under Open Gateway menu, which is our interface for configuring the cloud server as well as end devices. And in this case, we have a cloud agent functionality where we can specify what kind of protocol we want to use with the cloud. And in case of this demo, we'll be using ORing MQTT. And after choosing this option from the drop-down menu, you will see a menu where you need to add information about your server. So, as we know from our documentation, our server address is mqtt.pas.oringnet.cloud, so I will simply copy it to our gateway configuration. But you need to remember that we need to specify it's a TCP://. For client ID, we can go to our PaaS console and copy the client ID. The same for the user, which is in this case identity. And for the password, we need to copy the secret and paste it to our configuration. The next step is specifying the publishing topic for MQTT broker. So in this case, we can also copy this information from the console. But all you have to remember in this case is that the topic is using $sign, and we need to mark it as a special sign with a backslash. So before each dollar in the topic definition, you need to put the backslash, as well as at the end of the topic, you need to specify the data bucket name. So in this case, it's sensors, as we just added it. And we have also some other configuration for timing. Let's leave it as it is. Simply, we can proceed to clicking apply button, and we should be able to see that our gateway and agent and subscribe status are connected and success. So let's wait for a second. Okay, and the status is changed to connected and success, so it means that our gateway is already connected and online. The next step will be configuring our Modbus TCP device. So as I mentioned, I have a notebook connected to the Ethernet port of our gateway, and I know I will be sending one simulated value from the Modbus tool. In this case, I just want to add one new data field inside our configuration. And after adding it, the new menu appears where you can actually configure the values being pulled from the end device. In this case, you have a chance to choose the type of the connectivity, which can be Modbus RTU, ASCII, TCP, raw data, SNMP. I will use Modbus TCP in this case. I know my device ID will be 1. It will be holding register, which address is 0, and the data length will be 1. Now the important thing is to specify the field name, which has to match our data shape, which we just created. In this case, it's temp. Another important configuration for Modbus will be the IP address of our Modbus device. In this case, it's my notebook address, so 192.168.10.10, and the port for Modbus is 502. Another part of configuration provides you a possibility to verify when to send the data, what type of data to pull and encode, and shape the data before it's sent. So in this case, you have a chance to verify the data always, so send always on the time interval, send the data when it's different, equal to, larger and smaller than the threshold you can specify in the next field, as well as you can send the data when it's changed. So in this case, because I want to save some bandwidth, I will send the data only when it's changed. So I will choose option 7. I will pull the data as an integer, and I also want to send an integer for demo purposes. And I won't change the expression. I want to send it as it is. And I want to pull the data from end device, so I will mark this option in this field. After we have the configuration, we need to click the Add button and apply the settings to our agent. We need to wait for a second to establish the connection. In the meantime, I will open the Modbus simulator that I have, so Modbus slave tool. I will open the connection on the IP address I just specified and on the port I just specified. I will put some value in the register 0, which we also just added to our configuration. Let's make it 10. And let's go to the status menu and see if it is able to pull the data. Yes, so as you can see in the status, we have our table with the field name temp and the query value, which is 10. After this is done, basically the data logger should be already able to receive the information from the gateway. So let's check it. Let's go to our console. Let's refresh the things list. You can see that our gateway is already online. Let's choose it. Go to the data menu. Here you can specify what bucket you want to check. In this case, it's sensors. Choose your shape and click search. Yes, so in this case, you can see that we are already sending the data to the cloud with its timestamp. Currently, it's 10. When I will refresh it, you won't see any new data because it's not changing. In this case, I will go again to the simulator. I will change it maybe to 15 degrees. And now, if I will refresh the browser, the interface, you can see the new data appeared in the data logger and it's stored with this timestamp. Okay, so that was very quick and easy to get the data from our Modbus device and store it in the cloud platform. But this is only the data logger. Now we want to visualize the data in a very readable and user-friendly way on a nice user interface. So why not to use Node-RED for this purpose? So Node-RED is already built inside our cloud platform. It's available under the flow menu where you can work with the nodes provided by Node-RED as well as the nodes provided by ORing. So the good thing is that ORing already created nodes which are available from the library. It's a node for creating the connectivity between end device and our PaaS, as well as some adapters for dashboard components, which are chart and gauge. However, to make this work first, we need to go to our application menu and add new application and later use the settings of the application inside our PaaS Think node. So let's do it as a first step. In the application menu, we simply need to create new application, add its name. Let's make it IMG-4312D Demo app. Let's add some description. This is our demo app. And we need to specify mandatory redirect URL. In this case, we can use something like http://localhost port 3000. And once this is done, we can click Create button to add this application to our system. And once the application is added, you can see it's already added with its unique identity in secret. And when you are ready, you can generate its own unique API key. So let's do it right now. And the API key is generated. So I need this information to be put inside the ORing PaaS node. In this case, I will leave this window open for a while and open the flow window in another window. Yeah, let's refresh it. Yes, so our Node-RED is back. In this case, I will use a new Node-RED node in our workspace. So it's so simple that you just need to select it, drag and drop in the workspace, and double click for configuration. We need to specify new configuration. So in this case, it's our app name. Our app is this one. App identity, which we can simply copy. App secret, copy and paste. And API key, which we just generated, copy and paste. Update the node. Now we have our app configuration added in the properties. Now we need to add our thing name. So let's go back to our thing. And copy the identity. Identity is this field. And thing name is, of course, IMG-4312D demo. After clicking done, our node should be already able to connect with our thing. And now we want to visualize our temperature data maybe on a gauge. So I will use first our gauge adapter and put it in the workspace, as well as I will go to our dashboard components and choose gauge from the menu. I will simply connect them, add configuration to the gauge, which is the data and identity. In this case, it's our temperature. And we can add some settings for gauge. So here you can specify to which group it belongs. So later how it will be grouped on the dashboard. Let's make it default and home. You can specify the size, you can specify the type, for example, gauge, donut, compass level. Let's keep it gauge. We can specify a label. Maybe let's add temperature, value format, units. Let's make it C as a Celsius degrees. Range depending on your range of the temperature sensor. Maybe let's make it 40. You can play with some color gradients. So for example, let's make it green until it's 15, and between 15 and 25, let's make it yellow, and then above 25, let's make it red. We can click done, and after we have this, we can deploy our project. Everything is successfully deployed. We can see that our node is connected. Now we can go to our dashboard settings. Here is a list of the groups. We can choose a theme, for example. Let's make it dark as I like it. And once it's done, you can also go to the layout and choose the layout. If there are more components, you can change their size. You can locate them in the different position on the screen. But we have just one component, so there is no more configuration. So let's make it a little bit bigger and click done. Deploy our settings and open our dashboard with this button. So now you can see this is our temperature gauge that we already added and configured with our gateway. Now I will restart our Modbus slave. Okay. I will check if our gateway is running fine. Okay. Let's make it 10 degrees, simulated value. Let's go back to our dashboard. And you can see that the value is updated on the dashboard. After I will change it, for example, to 20 degrees, the value should increase on the dashboard, change its color. Let's make it 30. So each time the value is changed, the value in the dashboard is being updated. So that was a quick guide of the quick connectivity between end device and our cloud platform using Modbus TCP protocol and MQTT protocol, and our gateway product was IMG-4312D. Thank you so much.